So today we're going to be in a new section. We're going to be talking about linear and quadratic equations. And so this is going to be the new section, and quote-unquote section 10, but it's going to be a review section. And so we're going to go over factoring trinomials, the difference of squares, and the sum and difference of cubes. So today you guys are going to be able to factor a trinomial, difference of squares, and the sum and difference of cubes. So when I talk about a quadratic function, I mean it in the form of ax squared plus bx plus c, where a, b, and c are going to be real numbers, meaning they can't be like I or imaginary numbers. And we have to make sure that a doesn't equal 0, because the moment that a is 0, well, that would be gone, and then if that's gone, well, now it becomes a linear. So there has to be an a that's not 0, so that it makes the equation into a quadratic one. And also the domain of all quadratic equations are going to be from negative infinity to positive infinity. So we immediately know that our domain is going to be all real numbers. So the first type of factoring we're going to be going over is going to be factoring a trinomial. Now, one thing that we should always look forward to when we are trying to factor is always to see, is there a number or a variable in common? And we call that the greatest common factor. And you always have to factor that greatest common factor out first. So in this case, there's a 2 in common with everything, and so I want to factor out that 2 first. And so I'm left with x squared, and then 11x, and then plus 10. Now that now that the GCF has been factored out, now I want to list all the factors of a times c. So we said that this is a and this is c, so 1 times 10, I get 10. And then find all the factors that add to b, so then 1 times 10, 2 times 5, and so I'm listing all the factors there, and I know that I need to get to negative 11, and so this is going to be the way I get to negative 11. It's going to be negative 1 and negative 10. And so now, this is where it is going to seem kind of weird, but I want to rewrite that minus 11x that I have here, this b, in terms of these factors. So I still have that 2, I still have the x squared, but instead of minus 11x, it's going to be minus 1x, minus 10x, and then plus 10. And so I broke this down into these two here. So now that I've done that, the rest is just factor by grouping. And so what's in common here, I'm just going to ignore the 2 for now, so I'm going to ignore that 2. So I factor out an x, and if I factor out an x, I'm left with x minus 1. If I factor out and say a negative 10 up there, so I'm going to be left with x minus 1. And so when we factor by grouping, whatever's the same, you rewrite it. Then whatever's in front, you put into the other parenthesis, and now I can't forget that 2. And so there's my answer there. So what I did here, the first thing is I factored out a GCF, so I factored out this 2 from all 3 terms here. Then I listed all the factors of a times c, so here's my a times c, and I listed all the factors. What times what gave me 10. Then the third step, I found the factor that added to b, so negative 10 and negative 1, so I found it. That gives me that negative 11. Step 4 is I rewrote b in terms of the factors. So instead of writing minus 11x, I wrote the minus 1x and the minus 10x that I got here. Now, just to know that we're mathematically correct, negative 1x and negative 10x do equal that negative 11x. And then the rest is going to be factor by grouping. So I do the dotted line down here. What's in common here? I can factor out an x, and so I'm left with x minus 1. I can factor out a negative 10, which I did here, and I'm going to be left with an x minus 1. And so whatever's the same when we factor by grouping, we put here. Whatever's in front, x, and then negative 10, we can put on the other parenthesis, and then I can just bring this 2, and that's going to be my answer. My next one, I have 2x squared plus 3x minus 9. Now, one thing I just want to point out is some of us probably said, oh, well, look at this is minus 1, minus 10. Oh, that must be the pattern. Why do I have to do all of this when I can just do this quick shortcut? Well, just know that in this next problem, we're going to notice that that shortcut isn't going to work. And so the first step, factor out a GCF. Well, there's nothing in common with those 3 terms, so we're good there. then list all the factors of a times c. So 2 times negative 9, that's going to give me negative 18. And listing them all, I get 1 and 18, 2 and 9, and 3 and 6. And so now 3, find the factor that adds to b. Well, I want a positive 3, so this one would work if I do negative 3 and positive 6. Step 4, rewrite b in terms of those factors. So I need to rewrite b in terms of the factors. So I have 2x squared still. Now instead of 3x, I want to write it in this term here, so minus 3x and plus 6x, and then I have that minus 9. And so now, what I can do here is I have to do factor by grouping, which is step 5. So what's in common here is going to be x, and so I'm going to have 2x minus 3. What's in common here is going to be 3, and so I'm going to have left is 2x minus 3. And so whatever's the same, you rewrite it, and then whatever's in front goes in your other parenthesis. And so that's going to be your answer. As you notice, this negative 3 and the 6 didn't work for that pattern here. And so that's why it's nice to do this algorithm, because now we're not memorizing all these different exceptions and all these different things to try and figure that out. The other thing is it doesn't matter which order I did this. So if I did plus 6 and minus 3x here, it would work out exactly the same. So it does not matter which order that we have to do this. On this practice here, factor out the GCF. Well, there's nothing in common with these. And so list all the factors of a times c. So a times c, that's going to give me 60. And so the factors would be 1 and 60, 2 and 30, 3 and 20, 4 and 15. There it is. So I figured that out. So now I can rewrite my b in terms of those factors. So I have 5x squared plus 4x plus 15x and then plus 12. So now it's factor by grouping. There's only an x in common here, so I get 5x plus 4. What I have in common here is going to be 3, so I'm going to be left with 5x plus 4. And so now rewriting this, I get 5x plus 4 and then times x plus 3. And that's going to be my answer. So now let's talk about the difference of squares. So with the difference of squares, it's good to follow this algorithm here. If I had a squared minus b squared equals a plus b times a minus b. Now it helps that in our head, if we identify what a and b are, all we have to do is just plug it into that pattern. Now why is it important for us to memorize this pattern or learn this pattern is because we're going to see it naturally in other math concepts. And so being able to recognize this pattern is going to be able to help us simplify or manipulate other types of math problems. So it's important to memorize, it's important to know and be able to recognize it. And so the idea, like I said, well, if this is a squared, then the square root of that's going to be a. If this is b squared, then the square root of that's going to be b. And so that's going to be what we can do to kind of assist us in that. So for this first example, this 4x squared minus 9, well, a is the square root of that, and so that's going to be 2x. b is the square root of the 9, and so that's going to be 3. And so being able to simplify this, you're going to say a plus b times a minus b. And that's your answer. Now don't let the order fool you. Okay, my a is going to be 4. My b, the square root of x squared, is going to be x. And so this is going to be a plus b times a minus b. And so that's going to be my answer there. And what if I had a problem x to the 4th minus y to the 4th? Well, then my a is going to be x squared. My b is going to be y squared. So a plus b times a minus b. Now this factors further, so this is going to be x plus y times x minus y. And so this right here is going to be my answer. So just know, even though I factored this, this was able to factor further, and we should be able to recognize that. Now we're going to go over to the sum and difference of cubes. This one's a fun one just because we get to sing a song when we do it. Now just like with the sum and difference of squares, or just the difference of squares, notice this had a pattern that it factored into. Well, so does the sum and difference of cubes. It factors out into this pattern. We do need to find the cube root of this and the cube root of this. That's how we get our a and b. And then we just plug a and b into the rest of this, and then notice our plus stays the same, changes, or it's always positive. The same, changes, always positive. I mean, however you want to memorize that, go for it. But I think it's much easier to do it when we memorize the song. Now, when we sing the song, just know we do have to set it up. So I have to take the cube root of this and the cube root of this one, so I get 2. And so once we do that, we can start singing the song. And so I'm going to say this is first, and this is going to be last. And so when we do that, we can start singing it. And so the way it goes is first times first is first. Last times last is last. First times last is in the middle. Isn't this a blast? The first sign's from the problem. The second, it's reversed. The last sign's always positive no matter what the first. And so there's your answer. So let's try it again, but I'm going to sing it a little slower. If I have z cubed minus 8, we still have to set it up, so we get z, and the cube root of 8 is 2. And so when we go through and sing it, it goes first times first is first. And so I can say that that's going to be z squared. And then it goes last times last is last. And so that's going to give me 4. And then it's going to be first times last is in the middle. Isn't this a blast? The first sign's from the problem. The second, it's reversed. The last sign's always positive no matter what the first. And there's your answer. So this right here would be your answer. Let's look at another one. So setting it up, I have to find the cube root, so I get 3x. Whoops, that would be 3y. And then this one right here is going to be x. And so now that I have that set up, now I can go through and factor it. So it goes first times first is first. So that gives me 9y squared. Last times last is last. So that gives me x squared. And then first times last is in the middle. Isn't this a blast? The first sign's from the problem. The second, it's reversed. The last sign's always positive no matter what the first. Let's try this one. So I have to take the cube root. Now if I take the cube root of this, this is going to give me a squared. If I take the cube root of this, this is going to give me b squared. And so I have those values. And so this is going to be setting this up. So singing the song, first times first is first. Last times last is last. First times last is in the middle. Isn't this a blast? And then the first sign's from the problem. The second, it's reversed. The last sign's always positive no matter what the first. So that's going to be our answer. Now notice this factors further. It's a difference of squares. So this will factor into a plus b times a minus b, and I still have this a to the fourth plus a squared b squared plus b to the fourth. Now if you're wondering, well, does this ever factor? The answer is no. That does not factor further. To close this lesson, what did we learn today? We talked about different factoring techniques, and I want to hear from you guys, what are those types of factoring techniques? So also I want to hear, does a squared plus b squared factor? And what's the one thing that you always need to do first, or at least check first, when you're trying to factor? This does conclude our lesson. If you have any other questions, please leave them in the comments.